Okay, so let's take a look here at a recap of 2.4. I think it's 2.4 is the trig, and then 2.5 is the chain. Yes. So when we were evaluating, let's say, trig functions, you still verify, right, that tangent of 6t is sine of 6t over cosine of 6t, and then that is going to yield that's going to yield 0, and then sine of 2t is going to be 0, so you have it in indeterminate form. And the trick with this here is making a substitution in the form so that we're able to evaluate the limit as x approaches 0 of sine x over x. So this is going to require some algebra manipulation. And now we're focusing on the variable of t. So this is the same as the limit as t is approaching 0. Tangent of 6t, we just said, is sine of 6t all over a cosine of 6t. And this is times 1 all over a sine of 2t. Oh, t. Now, when you evaluate, cosine of 0 is 1, so we're okay with that. So, this is my manipulation, what I try to do. The limit as t approaches 0, I'm just going to leave this as 1 all over a cosine of 6t. But in this case, I have a sine 6t here, and then I have times 1 all over a sine 2t. So what do I need to have here? So I need to have this become, I need this to have a 6t here, 6t, and therefore I would need this to be a 6t there. And then over here, if you take a look, I would need this to be a 2t here, and then I will multiply this by a 2t there. And take a look at what's going to happen in this algebraic step here, that this t and that t are going to cancel. And this 2 will go into that 6 3 times. So now what you have is the limit as t is approaching 0. We said that this was going to be a 3. I'm just going to write this 3 over the cosine of 6t. And then we said the t's cancel. So this is going to be the sine of 6t over 6t. And then times 1. We said the 2 and the t cancels. So this is a sine 2t all over 2t. And the trick is, right, when the argument and the denominator are the same, that is another way where if you want, well, we're not supposed to say if we want to, no one wants to do this. You're going to let u equal 6t, and I'm going to let v equal 2t. So when you write this limit here, as this is still t approaches 0, this quantity is going to be 3 all over a cosine 6t here. But this is going to be times the limit. Now this is u approaches 0 of sine u over u times, this is the limit as v approaches 0, but this is 1 all over sine v over v. So when you do your direct substitution here, you're going to get 3 times, and then this is going to give you a 1, and then this is going to give you a 1, and therefore I yield 3. Okay, so now we're going to pick up in 2.5. We saw a few examples last class meeting using the first definition and the second definition of the chain rule. There was a few videos as well that was using the third definition of the chain rule. And what the third definition is illustrating is that we could use 2 different rates of change, 2 different rates of change by taking their product to find the derivative. And what that was illustrating is, you know, your inside function g here, which is in with respect to x, if we let that inside function equal u, then what do we have? We're finding the derivative with respect to x of f evaluated at u. And again, it is the derivative of the what? The outside function evaluated at the inside function times the derivative of the inside function. But the derivative of the inside function now, because u was replaced with g of x, the inside function is du dx. And oftentimes, rookie mistakes is not following through using this definition, so I just wanted to recap on that. Now, also, what I've decided here is that you need to have this, the derivative of sine x memorized, the derivative of cosine x memorized, and the derivative of tangent x memorized, and then I will provide you with the following 3. And so it's the compromise that I'm at right now. So when you take a look here at this example, and it says, write the composition in the form of f of g of x, identify the inner function, identify the outer function, and then find dy dx. So if you take a look here at, let's say, 4, what this is going to illustrate here is u is going to equal the inside function, which is cotangent x, and y is going to equal sine of u. So when you find the derivative, you're going to get du dx is going to be a minus cosecant squared x. Here you're going to get dy du is going to be cosine of u. So when we find dy dx, we have dy du times du dx, which is going to be a cosine u times a minus cosecant squared x, but you have to replace u back, and so you're going to get cosine. U was cotangent x, and then this is going to be a negative times a cosecant squared x. And if we don't follow these directions, then we will be penalized. So it's just showing you that there are 3 different approaches to find the derivative of a composite function here.